I have a job as a math tutor, and sometimes a question that my students will like to ask me is, why can't we divide by zero? Um, and sometimes when students ask me that, I kind of just want to go on and on and on, because dividing by zero is actually a really cool concept, and we've established a bunch of definitions for zero. And I could talk forever, except I think their parents would be pretty unhappy with me if I tried to do that and ignored the problems that they're given. So I usually give a pretty brief explanation, but I kind of just want to get it out of my system at this point because I'm asked it all the time. And hopefully this isn't an annoying video to make, but I want to talk about why we can't divide by zero. So to figure out why we can't divide by zero, I think a fair question is, how do we define division to begin with? So a person could define division is, how many times does something go into something? So if we were to say 15, and I'll put this up here, you might not be able to see it because of my Mac. You could say something like 15 divided by 0. You could come up with the definition. Okay, well, division is defined as how many times something goes into something. So you could say that this is the same thing as asking, how many times does 15 go into 0? And I think a person's intuitive response to that question is, okay, well, 15 doesn't go into 0 any times. So is it fair to say that 15 divided by 0 equals 0? Question mark. And I think that's a hypothetical answer to this question. And I'm going to come back to it. Let's just keep that in mind. Let's keep that in the back of our minds. Okay, well, now let's come up with a different definition of division. And in order to define division, I think we can say, okay, this is kind of like multiplication. Let's define multiplication first. And I think a fair way to define multiplication is repeated addition, right? And so let's try it. Let's do 15 times 3. And this is the same thing as saying 15 plus 15 plus 15, and we would get 45, which is the same thing as 15 times 3, right? So I think repeated addition is a fair definition of multiplication, or at least a very brief definition of multiplication. And so if we accept that definition, we can say, okay, well, fine, how do we define division? And we already have one definition. Let's try another one. We could say that division is defined as repeated subtraction. So now let's try 15 divided by 3. This is the same thing as saying 15 minus 3 minus 3 minus 3 minus 3 minus 3, and we keep going, and eventually we're going to reach 0. We're going to get equals 0, and we can look and we can say, hey, I noticed that there are 5 values in this set, so is it fair to say that 15 divided by 3 equals 5? I think yes, that holds true. That's a fair definition. Repeated subtraction. Now let's try 15 divided by 0. Okay, well, under this definition, we could say, let me just erase what I have here. We could say 15 minus 0 doesn't get us where we need to be. Minus 0, minus 0, minus 0. We can just keep going and going, right? And so this turns out to be a kind of different definition, right? Or a different potential answer, because now we could make the argument that 15 divided by 0 equals infinity? Question mark? Okay, well, let's try a different way to approach this. So I think that I'm going to work with 1. I think 1 is an easier number to work with. I'm going to do something like 1 over 1, 1 over 1. We know that that's just equal to 1. Okay, let's try 1 divided by 0.1. 1 divided by 0.1, we know that's equal to 10. Okay, let's keep going. Let's do 1 divided by, let's do 1 divided by 0.0001. We could say that that is equal to, yep, 10,000? I don't know. Got to double check my mental math. Something like this. And we can keep going and we could say, hey, this is approaching 0. It kind of looks like it's approaching infinity, right? Looks like it. Let's think about limits. The way that we define a limit, and it's okay if you're watching this and you haven't taken a calculus and you don't know about limits yet. It doesn't matter. I'll explain it anyways, but for those of you that have taken calculus, this is just a fun little treat. Not like anybody's gonna watch this. This is my secret YouTube where I get things out of my system. So let's try a different way. So for limits, we could say that this is approaching it from the left, but that's just a fancy way of saying let's get really close to 0 from the negative direction. And so let's do 1 divided by -1. We know that that is equal to -1. Now let's try and get 1 divided by -0.01. We know that that is equal to -10. Let's take another jump. 1 divided by -0.0001. We get -10,000. I think it's 10,000. Sorry if I fact check this later. I spent too long thinking about that and I just wanted to move on. But here we could say, okay, well now I'm noticing a new pattern. Is it fair to say 1 divided by 0 equals -infinity? So we've done a few different calculations under our definition of division, and we have come up with 3 potential answers. So the 3 potential answers that we have come up with, just to review, under our definition where we can say that division is how many times something goes into something, so we could say 15 goes into 0 times, so 0 is a potential answer. Then with repeated subtraction, we found infinity as an answer. With repeated division, where we got really, really close to 0, we found both positive and negative infinity as an answer. So these are our 3 answers that we have so far. And so we can say, okay, well, this is starting to look like it's undefined. And undefined literally means we can't define it. So we can come up with various different outputs. I don't know, we can't define it. And so if you think of it in limits, you can think of it as it doesn't work because the definition is different. If you aren't familiar with limits, you could say that it doesn't work under any definition that we fall under. If you aren't convinced, let's do one more proof. Let's say that one of these is correct, and we can pick any of the answers that we want. Let's just say equals infinity. Okay, so we can argue that 1 divided by 0 equals infinity. Now let's try 2 divided by 0. We could say that that also equals infinity, and I'm just skipping steps now. if you want, I can prove it further by doing 2 divided by 0, or 2 divided by 2, or no, just kidding. 2 divided by 1 equals 2. 2 divided by 0.1 equals 20. 2 divided by 0.001 equals 2,000, and so forth. And we can see that this is also approaching infinity, just at a quicker rate, right? So we have 1 divided by 0 equals infinity, and 2 divided by 0 equals infinity. Okay, well, let's use simple mathematical rules. If both of these things are true, then both of these things must be true, right? And so is it fair to say that 1 equals 2? I would say no. I think that defies everything that we know about mathematics, and it doesn't work. And we can prove it over and over again. We always get the same output. It's undefined, and it doesn't work. And I always give my students a lazy answer, but here's the long one. Hopefully this video isn't too annoying.